Hey guys. So today we're going to take some time to go over something that I'm sure gives everybody a lot of stress. Organic synthesis problems. I know that synthesis is one of the most difficult parts of OChem for a lot of people. It takes time and practice, but I'm going to go over a few strategies here that'll help us figure out how we can go from hating this problem setup to getting full points on any synthesis problem that's put in front of us during an exam. So in the displayed synthesis problem, we can see that I've drawn in 2-bromopropane in as the starting reactant and asked you to produce 2,3-dimethyl-2-butanol as the product. We're going to try to do something called retrosynthetic analysis, where you look at the product, try to deduce what its components are, and see how they relate to the original reactant. That'll let us know what we need to do to get the reactant to be the product. The things we're going to look out for are understanding these things will help us figure out what we need to do to make our product. So let's start by counting our carbons. In the reactant, we have 3 carbons. In the product, we have 6. This is good. This lets us know that we only need 2 of the reactants to get the adequate number of carbons. To find the differences in the substitution between the products and reactants, we just need to do a quick compare and contrast between the two molecules. We can see that we have 1 bromine substituent in the reactant and 1 alcohol in the product. Now, we need to figure out why these groups might be present in one molecule but absent in the other. If we think about the relative properties of bromine, it can act as a very good leaving group in SN2 reactions. It can also act as a component in other reactions, like Grignard's. Oxygen is capable of being reduced or oxidized, so having this in the molecule creates a site for potential electrophilicity, meaning that it's a good spot for nucleophiles to want to attack and create new bonds. This is a very, very important point for us to keep in mind for later. Finally, to examine the bonds broken and the bonds formed, we just need to take a look at where we can see the original reactants within the product. Here is the product, and here is the reactant for reference. As you can see in the product, the only way that we can include 2 molecules of the reactant would be if we created a new bond at the 2 position of both molecules. I've drawn in the numbers as if the product was composed of 2 of the reactants to help you visualize this if it isn't really clear at first glance. Once we figure out how to create this new bond, then we'll be able to attach the 2 components together. Now, since we've gone through and examined the molecule, you may have an idea about how to go about doing the synthesis, which is fantastic. If not, that's 100% fine. We'll get through it together. This part is a bit harder because you're going to need to know reactants and reagents out of your back pocket. My recommendation for this is to burn through complete the reaction problems until you become familiar enough with the reactants and reagents to employ them and use them in novel synthesis problems. So let's start the synthesis. We know that our product's going to need to have an oxygen, so we can reasonably assume that's the path the reaction takes to create a new carbon-carbon bond. In order to do that, we need a carbonyl, not an alcohol. So let's treat this initial reactant with hydroxide and then PCC to create the carbonyl. Now the last step is to create a nucleophile powerful enough to make a new carbon-carbon bond. There are a lot of reagents that do this that you'll learn throughout both OChem 1 and OChem 2. But the important one right now to remember that we're going to use is a Grignard reagent. So just treat this first reagent with magnesium and a polar aprotic solvent such as diethyl ether or ET2O, and we can create our nucleophile. Simply put the 2 together, do acid workup to protonate the oxygen, and you have your product. I hope that this has helped you strategize how to get through synthesis problems. Remember, you need to figure out 3 things. 1. How many carbons are in the product versus the reactant? 2. What new atoms have been added to the product and what atoms have been removed from the reactant? 3. What new bonds are formed within the product? If you've done all these things and you have a good grasp on all the reagents that you're taught, you'll be able to tackle any synthesis problem put your way. If you have any specific questions, feel free to schedule an appointment with any of the great OChem tutors at the study lab. Stay safe.